You're listening to the Hour of the Time. I'm William Cooper. Ladies and gentlemen, without further ado, we take you to our Conference 97, fourth day, Thursday. Ron Howell. Pay attention. You're going to love it. Everybody who attended thought this was one of the best lectures they heard. It will open your eyes. It will challenge your intellect. It will cause you to ask a lot of questions of people that you always believed blindly before. And it'll make you laugh.
Good afternoon. That was a lot of fun with Jeff on the radio. And I bet you that there was a lot of people out there that really enjoyed that. What you're going to hear now is going to be extremely interesting. You've heard me talk about the Apollo moon shots and the Apollo mission and the Apollo program and all that kind of stuff on many broadcasts. And you've seen all of the NASA footage of that and the special programming on TV of the Apollo program. And the next speaker has done a lot of research on this and put together the results of what he's discovered. And he's going to share that with us for the next 2 hours. He's also a good friend and a major contributor to our effort. This microphone up here is one that he gave us that we can travel with. It has incredible quality because we can't travel with the 2 other microphones that he gave us because they're so fragile, and they were made back in the 20s and 30s. And they're the best microphones ever made. You can't duplicate it with solid-state technology, and that's what makes the Hour of the Time sound so great. So his name is Ron Howell. He's standing right here, and he's put together the results of his research into the Apollo program and the Apollo moonshots, and he's going to give you the results of that over the next 2 hours. I think you're going to find it extremely interesting. Regardless of what you may believe about what happened, you're going to find what he's going to tell you interesting. So pay attention, take notes, and I don't know if he's going to take questions, but if he does, please hold your questions until the end of his presentation so that he can get all the way through it. And if you can poke holes in this, that's fine. I happen to, I pretty much think I know what he's going to say, and I think I pretty much agree with him. But Mr. Ron Howell.
Thank you, Bill. Well, with a nice introduction like that, I don't want to fall flat on my face, so let's get to it here. This outline, or my presentation, is called Did NASA Fool America? Now, I have to tell you, you don't have to believe what I say. If I were to tell you that we didn't go to the moon, I wouldn't expect you to believe it, but you know that. You deal with intelligence every day, and you know you have to treat it as such. If it's evidence, you have to handle it for what it is. If you agree with it or not, that comes later. Even if I were to tell you that I went to the moon myself, you couldn't accept that. You'd have to look at it as secondhand information, wouldn't you? Okay, now, we are going to discuss facts, and we want to get to the truth, because I appreciate truth. Everything that deals with freedom, has everything to do with truth. Now, let me see here. I was going by my little outline. Okay, this is an experience I had. When I was in high school, I can remember that the Apollo project was going on because I was a senior in '69. I remember seeing the footage. And my feeling at the time, I was a sheeple. I was young and impressionable. When I saw these moon astronauts, I knew. See, when you're in the vacuum of space, you know that death is right outside of you. Right outside of your suit is a pure, hard vacuum. When pilots are inside of an airplane, they're in a pressurized cockpit, besides being in a pressure suit. So being outside of a capsule, being on the moon, I knew at that time that it was very dangerous. And my impression was that these men were very joyful, they were happy, they were jumping around, right? And my thought was that these men must be awfully brave, knowing that they may die at any minute, that they're going through, that they're entertaining these thoughts, and they figure, what the heck, we're going to live this up while we do it. I was thinking that, or it could be that it was fake. I thought it was just too dangerous to be acting that way. And, I brought this up in school, and, the teachers, the kids, they put that down. So I let it go for a long time, but I always had it in the back of my mind. Then about the time when I was getting older, I knew there was trouble in the country. I acquired a shortwave set. I instinctively knew that shortwave would be what I'd want to look for. I'd want to search the dial. I thought, to tell you the truth, I thought I'd be hearing information from outside of the country. I never thought it'd be coming from within. And when I heard, all these shows, I was like, ooh, knocked out. And then, 9 o'clock Pacific time, that old siren came on, and boy, I knew that was something. So I really listened to him. I know, I'm not used to this, so I gotta get used to laughing at myself. It's not a problem, I'm just getting used to it here. So, listening to the show, I remember one episode where he was talking about the astronauts on the moon in 1/6 gravity. And seeing that show, it was like, hey, I was thinking this a long time ago, and here he's talking about it. I felt somewhat empowered that my thoughts weren't so off base. Listening to his program, and shortly after that, maybe a year or two, he came out with this book, NASA Mooned America, by a man named Rene. I still don't know if that's his real name or his last name or what. I obtained his phone number before I was able to do this. I haven't been able to talk with him yet. So a lot of my material is going to be based on this. And I know a lot of you people out there have it already, because in my short acquaintance with you, many of you have it. But I don't plan to do a book report on this. When I obtained this book, it was so enlightening, it inspired me to hit the books myself and see if I could back it up, see if I could poke holes in it, substantiate it. It was something that just made me really want to study. So that's what I've been doing. And also I've got this other publication, this book he published called The Last Skeptic of Science. The book meant to try to stop, and it's a kind of a collage of different papers that are associated with subjects like this and other things we'll be referring to. So, I just looked at my list here. I've got so many things to talk about. I had to write in an outline to get it. I'm being just a little nervous. It's hard to read it. Okay. When I was doing research, I went to the old Popular Science. Has anyone ever seen one of these or seen the Popular Science? Okay, well, I've seen it a lot. In fact, I've seen it on TV shows. I remember one episode of Heart to Heart, and it was right there in the library. I remember saying, yeah, that's the one I've got. So I checked it out, and I found this set at a swap meet, because the set that my father bought me years ago was worn and tattered. When I was a kid, I read all these books. I was always interested in how things work. So I saw this set at a swap meet, and I bought it for $10, brand new, sealed and everything. So if I can tell you here, okay, one of the things with the moon, I wanted to get some information on the moon, because many people take the moon for granted. We have ideas about it, but as you'll see when I show you these demonstrations, you'll be knocked out, because it has nothing to do with what you think. Now, you can find the distance from the Earth to the moon, of course, in these volumes. But I just want to take a chance and see if anyone has an idea, or how many people in general have an idea how far it is to the moon. Any thoughts?
249,000.
Okay, well, see, I was afraid of that. You people are really up on this. Well, okay, let's go to the next step. Do you know how they found out how far away it is?
Yeah, they used, amateur radio did it by radar, I think, the first time.
Okay, years ago, before radio, how do you suppose they did it? They knew how far the moon was away way back when they built the pyramids. Now, you think about that. How did they do it? Well, I'll show you. I wish I had a big blackboard here, because it's a good crutch. I don't have to fool with things. But generally, the Earth is over here, and your moon here. Okay, well, how they determine how far away this moon is from the Earth is they know two locations on the Earth, the distance, not the circumference, but the distance through. Oh, that's a real strong shock here. Okay, the distance through the Earth from this point to here. See, they figure that distance, and then to the moon here, you have a triangle. So if they know the distance from here to here, and they measure these angles, they can determine the distance from here to there, to the middle. Right, okay, and of course the reverse works too. If you want to know the diameter of the moon, what you do is you know your distance, then you calculate points where the angle is, and that would see, from this part of the Earth, you would measure a triangle this way, and then of course you know the angle of the triangle on this side, and that tells you the diameter there. So is that clear? We understand? Okay, so the diameter of the moon is 2,116 miles. The diameter of the Earth is 7,927 miles. Okay, now those facts are in this book, and they're there for all of us to read. Okay, the question is, using these pieces here, how far, this softball is roughly the size of the moon, how far away in your mind's eye are we from this Earth? Let me get it. I especially got this globe here for this demonstration. I like it because I can take it out of there. It was nice to have one here, but it spins and makes it awkward. So imagine now we're out in space. Here's your Earth, and here's your moon. Now I'm going to ask a couple of you out there How far do you think it is?
25 times.
Hey, we got a smarty here. Maybe someone else didn't hear it. Any other thoughts? Any other? So he said 25 times. 25 times what?
125 times the diameter of the Earth. Because the Earth is 2,000 miles, and you said the Earth is 250,000 miles away from the Moon. So 2,000 into 250,000 is roughly 125 times.
Well, your idea of finding it is right, but I think it's wrong, because what you do is you divide 7,927 into 239,000, which is the average, because it's supposed to be an elliptical orbit. So just taking an average, that goes 30 times. So I'll throw you the moon, and you go out there and you hold that. Okay, do you see that?
Wow.
Now, there's a way that I can prove this. Is if I had a long pole that went to that baseball, and I was strong enough to hold it, and if the moon was in this vicinity, you hold that baseball up to that moon, and it's going to be the same size as the moon. So it shows that the scale is correct. Is that understood? Okay, now this is a mind blower. Okay, now this is a fact. If they really went to the moon, this is what they would have had to do. See, it's either one of two things. It's a great accomplishment, because imagine, that moon isn't stationary. That's a moving target. And you have your I'm not telling you how far off this yet, but it's coming off this globe, hitting a moving target, and it has to hit that target at right angle precisely to go around it. Because if you miss it, there's no second chance this is gone, right? Is that agreeable? Okay, you can bring that moon back. Thank you very much. Okay, now we know what they claim to have done. What are they doing today? We know about the shuttle project. We know about putting satellites in orbit, things like that. I should have thought I kept it here. Okay, does anyone know now how high the shuttle usually flies? I know you're sharp out there. What is it?
25 miles. Maybe 25 miles, maybe.
Well, it's a little more than that. It's 300 miles. 300 miles, they say. You know, we don't know. They say that. Okay, where do you suppose 300 miles off of this? It shouldn't take too hard to think of it.
Less than a quarter of an inch.
Right. Less than a quarter of an inch off this globe. And you can find that out because you divide 12 into 7,927, you get 660 miles to the inch. And if they say they go up 300 miles, that's less than a half an inch, isn't it? So here you go, that moon's out there, here's the Earth, and now we can prove this, because once you know that, this is a standard. See, this is a reference. Now, the way I look at it is when you look at those pictures they claim that they did out in outer space, what you do is you put your eye right close to that bulb, and you match the horizon, the curvature of the Earth, to what they said. And if it matches, it's going to be to scale. If it's not, it's way off. So here's an example. I've seen many, many times where they're shooting up the Atlas rocket, and you see these beautiful pictures of the stages dropping off with fire around them, and you say, "Ooh, man, look at that." Okay, well, when you see those pictures, you're seeing the Earth from about a distance like this. You see that curvature of the Earth like this, with those stages dropping off. Okay, now you look at that reference point from about here to here. You know, you're talking about this far. That's further than the United States. That's over 3,000 miles. So if they're dropping off first and second stages 3,000 miles off when they claim it's under 100 miles, there's something wrong with those photographs. So, am I right? There's nothing else it could be, because this is a standard. Okay, one of the things that they did back in July 1st, 1957 to December 31st, 1958 was called the International Geophysical Year, the IGY. You've probably heard of that if you went to college or something. It's UN stuff. They gathered all the scientists together. They're drilling and poking and measuring everything that they could to establish the old doctrine or the old measurements that they used to thought was right. Okay, they checked out, this geometry which we had before. They had devices that were called a Markowitz dual rate moon camera and a Dijon astrolabe, and those were devices similar to sextants and things that they attached to telescopes to accurately measure these distances for the moon, and that was supposedly for the upcoming moon project. So in a way they really confirmed the old things, because really we know that man was smart all along. It wasn't this gradual evolution that they were cavemen or something. I mean, it's obvious the Egyptians, they were very smart. Those pyramids, they say that they don't know how they made them even to this day, do they not? And I believe with my, my way of exposing this is going to show that man made them. It's not something from somewhere else. And we'll get into that later. Okay. When I was reading this encyclopedia over the years, it's in volume 1, by the way, on page 237. It's an illustration that I've never been able to find anywhere else, and I've been looking. Okay, this illustration here is like a graph or a scale that shows the different layers of the atmosphere. And it's interesting to note in one book I was reading that the breathable air that we breathe to this size of the globe is less than the thickness of the coating that they put on this. In the old days it said varnish, but this is a newer one that probably has some kind of poly something on it. But the air that we breathe on this globe here is actually thinner than this coating. So we're talking about these layers. Now, if I may, what I'll do is I'll get this erased and I'll draw. If you're taking notes of stuff, you might want to do this because it's leading up to a point that's very vital to understanding this. If you take your paper long ways like this and you draw a line for a horizon, I never knew until just a few months ago where that word came from, Horace Rising, but on this horizon. Now, I know now, okay, let me explain it this way first. In the old books, so you have to understand that all these things, airplanes, jets, rockets, it's all happened within 50, 60 years. So this is really new stuff. When we talk about these layers, in the old books, there is only 4 layers. But just before they went to the moon here, this was published in 1970, so I'm sure that the type was set and committee and everything when they made these books. This information is not to the minute 1970, but obviously before they went to the moon, it exposes other layers that they defined, and that's the ones I'm going to show you tonight. If you have your paper ready with this line here, on the very first layer, they call that the troposphere. So we'll put that one right here. Now the troposphere, we could define that. Well, I could more or less tell you, or I could read it from the book.
Blackboard.
Oh, thank you. Well, this is a real honor and a privilege for me. This man so many times, and he's helping me tonight. Thank you, Bill. Okay, the troposphere is defined as from 0 to 7 miles height. So from this area here to here is the zone we're talking about. Now I'll just read a little bit from the book because I could explain it, but it's better to get it right from here. The troposphere is 0 to 7 miles up. The troposphere is the air which all human beings usually have intimate contact, since it is the very stuff we breathe, and is also the seat of weather and climate. The troposphere is the densest part of the atmosphere. The air pressure drops with increasing altitude, and we have already pointed this out, that there is more water vapor and carbon dioxide in the troposphere than in any other layer. And it goes on, but basically what it's saying is that the air that we breathe is in this layer here. Okay, the next layer, which we're concerned with, maybe, I know there's a lot of smart people out here. What do you suppose it is? You know what it's called, anybody? I heard one. Stratosphere, correct. Okay, I'll define that one now as being 7 to 29 miles. Put another line.
Does that mean it fluctuates?
No, what I mean from 7 to 29 miles.
7 miles high to 29.
Right. It starts at 7 miles high, and then it goes to 29 miles. Here's something I couldn't understand. Even in the book, they say there's no fine line between the layers. So don't ask me why they call it 29 miles when it could easily be 30. I'm just telling you what it says here, and I don't know what their reasoning is, but they say it can vary a couple miles. There's no hard line as to where it crosses. But that's the definition from the textbook that we have. Let me go now to the stratosphere, what this consists of. The stratosphere is less dense than the underlying troposphere. It contains much the same gases, except there is less water vapor. The altitude of 15 miles, much ozone is concentrated, which we know the story about the ozone very, very well by listening to the Hour of Time. It absorbs most of the ultraviolet radiation from the sun and thus is heated. From a low of minus 60 Celsius at 7 miles, the stratosphere temperature rises slowly up to the base of the underlying mesosphere at about 29 miles. The temperature of the stratosphere increases in the summer. Well, think of something else, but I want to say, well, it's a lot of reading, but the point I want to make is that in the stratosphere, the temperature drops. From here, the higher up you go, it gets colder. And isn't this what we understand? Because when we look at the old World War II movies, we see the B-17s flying high. They're wearing those neat leather jackets I like, and they're way up there and they're cold, right? Well, that's how it was. But I'm afraid that gives people the illusion that the higher up you go, it keeps getting cold. Does anyone in here that has read their NASA Moon in America book know what I'm coming to or understand what I'm getting at? There's a hand back there.
In our concept of temperature, you have to have the density of molecules. When you don't have molecules, the temperature doesn't mean anything.
That's a good point. That's going to come later. But what I mean for right now is... Right, there we go. Doing okay? Okay.
Let's go up to art.
Okay, the next layer is the mesosphere. 29 miles it starts to 48 miles high. So that's your third layer. Now let's get to what the mesosphere is, how they define that.
That's 29 to what? 48. 29 to 48.
Yeah, well here it's 49, but that's close enough. Oh no, you're right, 48. Maybe it's because I'm a little nervous. What do you think, huh?
That's okay.
Okay.
You already told us it could be.
Right. Okay, the composition of the mesosphere is not unlike that of the stratosphere. The gases are less dense, of course. Carbon dioxide and water vapor are of little importance. The mesosphere has a layer of ionized or electrified air, the so-called D layer, extending 30 to 50 miles above the Earth. It is caused by the action of solar ultraviolet on the air molecules and is charged with electrons. Ozone also occurs in the mesosphere, where it is formed by the action of solar, ultraviolet, and X-rays on oxygen. The temperature from the low of 60 Celsius up to 7 miles in the stratosphere rises to 0 centigrade and altitude of 30 miles. Then it drops to about minus 90 at about 50 miles above the Earth, the surface of the Earth. So you see, in the mesosphere, it's starting to vary. Now, like I said before, in the older books, they were identifying that layer as being called only the ionosphere. When, if you understand anything about it, the ionosphere is anywhere from the top of the stratosphere all the way up to a different degree. You know, depending on what frequency you're transmitting at, they can determine how high or at what density level it bounced back or it ricochet off. And that changes through the years, depending on weather, temperature. You know, that's why when we try to listen to Bill on shortwave, sometimes it sounds great and other times you can't get it. And that's why. Now here they also define these other layers of the ionosphere, the D layer, E layer, F1 layer, F2 layers. So, you know, they have it pretty well figured out at what frequency, you know, it hops the best. Okay, now we're getting to the one that's really important. These lights here makes it hard to read. Okay, maybe I should put it on this board first. What do you suppose the name of it is? It's totally about what we're getting at. It's called, pardon me? No, that was the first one.
That's the ionosphere.
Well, remember that, maybe I should clarify, that the ionosphere was the old definition. As they were getting more knowledge about radio and radar and whatnot, they defined the different layers. And this layer they named, no, we'll get to that one. The thermosphere. You got it. He knows what's happening here. Okay, when I saw that, the first thing that came to my mind, thermosphere, what are we talking about? I thought it was getting colder. And usually when they say thermo, they're not referring to the cold part of heat. They're referring to a rise in temperature. So I knew I was investigating. I was on the right track here. So, the next one, which is the thermosphere, is defined as being from 48 miles high, starting to 250 miles here. Okay, wait till you hear this definition. There's no way they could teach this today. There is a wide range of temperature in the thermosphere. From a low of about minus 90 centigrade at 50 miles altitude, the temperature rises to several thousand degrees at 300 miles and higher into the exosphere. Okay, let me just say that one more time. The temperature raises to several thousand degrees. Okay, how much is several thousand? They didn't say what it is, but yeah, right. I think of several is at least more than 2, and I think it could be as high as 4 or 5, couldn't it? I mean, we're talking of a several, so that's what it says here. And now let me finish. It's not through. It says into the exosphere. A great deal of this intense heat, if not all of it, is due to the fierce solar energy and other kinds of radiation bombarding the atmosphere at those immense heights. The air is too thin here to offer much resistance, and there are no clouds to shield it from the constant onslaught. So there it is right there. What are they saying? Now, it's interesting to know, it's just a coincidence that in the same volume, here in the back, they're talking about the Bessemer steel process. Now, if you read what that is, it's a blast furnace of only 2,000 degrees at 300 miles an hour can take iron ore and melt it into steel. So here, with the same definitions found in this book, how is it that the Apollo space capsule traversed these layers and came back in one piece without them being in a molten piece of lead or something?
They have a heat shield. This is what I was trying to tell you on the broadcast when I said it couldn't possibly even go through the immense radiation of space. It can't. We haven't got the Van Allen telescope.
No, that's what we're getting to.
Normally it quite I think we've been snookers.
Okay, let me see, I think.
And this is just the beginning.
Right. Tell you what, in a couple minutes, I can call you back. How's that? Thank you very much.
I love your presentation.
What are you going to write a book?
I'm trying my best. Okay, now, I think it was mentioned, how can I phrase it? Okay, temperature is what? What is temperature? Temperature is the attribute. Well, what does temperature have to be associated with? It has to be associated with matter. Molecules. Okay. If you have matter, it doesn't matter what it is, solid, liquid, or gas, you have molecules of something. And heat is the acceleration of those molecules. When it's cold, it's going slow, okay? So, knowing that, what do you think the definition, the temperature of space is? See, because when they went there, when they were on the moon, supposedly, they were sitting on the moon. They said they were sleeping, but they couldn't sleep because it was too cold. That's just something. So, knowing what you know of what heat is, or what the temperature is, and knowing what space is, what is the temperature of space? Do you understand what I'm trying to say?
Depends on whether you're in the shadow or you're in the sun.
Right. Space wouldn't have a temperature.
Right.
Because space is a vacuum and it's the lack of matter.
Right.
And we can prove that. The thermos bottle, there's one right there. How do they make a thermos bottle? There's really two bottles in one. They evacuate the air in between. They put either hot or cold liquid inside. And not having the matter to trans through, or I should say penetrate, because I should have mentioned there are three ways of conducting heat. There's convection, conduction, and radiation. So how they make a thermos bottle to prevent radiation, they make it a mirror inside, nice and shiny, so when the heat goes out, it tends to reflect it back in. And the conduction and the convection is out because there's no way for that to happen through the thermos bottle. So what I'm trying to get at is space itself doesn't have a temperature, but anything that's in space will have the temperature. Okay, what they claim, what they had to do is because of the heat and the cold, when the Apollo craft was heading out to that moon out there, that it had to do that Dutch roll, they called it. Okay, and their logic to us was that, well, it's hot on this side, it's rolling over into the cold to cool off to go back into the hot again. See, so they want us to believe that's what they did, and think of the navigation problems they would have with this, because, they had primitive computers back in those days, and to go somewhere for a destination and to compensate for that roll all the time, well, we know it was never necessary because of the situation with the heat. Well, what really happened is, like it was brought out in the NASA Moon to America book, Renee used the illustration, you've got a hot dog on the barbecue. It's in the heat, it doesn't matter how fast you turn it, it's going to cook it all the way through. This is a good book. I've read it 12 times, and I still don't have everything memorized. This follow-up one here, well, I think it came first, really, The Last Skeptic of Science. If you have any inclination to these, these thoughts like this, it's a good read, because it crashes every major theory. And remember, a theory is not a fact. It's supposed to be an idea based on facts. So that gives you latitude that maybe that theory or that conclusion isn't the right conclusion, because there's other ways you can handle or interpret these facts to come to a different conclusion, right? So I heard it on the Hour of the Time that Bill mentioned that soon, and I thought he might have got the idea from this book, because the Einstein simple and the complex theory of relativity, it could fall any day based on some of these ideas. And so it's just very good, very good. But I better stick to this outline, or I'll get too far off here.
Which book were you talking about?
Oh, I was talking about the Last Skeptic of Science. The book Mensa tried to stop.
I've never read it.
Okay, well, what it is I believe he used to belong to Mensa, and because of the heat and the controversy over this book, that he's no longer a member.
Yeah, I heard that story. They kicked him out because of that book.
Was there a hand back
I
there?
remember the mention of that Dutch roll, that maneuver, even out the absorption from radiation and stuff, from radiant energy. Could you demonstrate that with a yardstick or something? I had no concept.
Oh, okay. Well, that's easy. And that brings to mind another point. I'll tell you what, I'll use that cup as a space cap.
Just as good as the one
Okay, that kind of looks like one, sort of, right? Okay, well, the Dutch roll was supposed to be that it turned on its axis like this. Like if that light was the sun and it's going to its destination, that it turned like this, supposedly so that this side would get heated from the sun, but it would roll over into the coldest space to dissipate the heat off and roll back into the heat, and that was the idea.
It's pretty like a bullet.
Right. Okay, but here's an interesting fact about this, is that when something like this is in orbit, you know, when you watch the space shows on TV, they always show, you know, I'll get my Earth here. You know, I go dun 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 dun, and the spaceship's going around like this, and it's always heading nose first around the Earth, right? Well, that would be true if the capsule was powered or being pushed to go around the Earth. But in reality, it's orbiting the Earth, and there's nothing pushing it. So instead of it going nose first, it would go this way, and the nose would still be aimed the same way it was going, and then it'd come back around this way, backwards, and then go around like this, or it'd be at the whim of whatever force might happen to take it. There's no...
Nothing can change the inertia.
Right. So when...
Another fraud.
Right. See, that blows a lot of things away, because, see, they're talking about taking photographs and different experiments that they did, and was dependent on that idea of doing that, but it couldn't have happened.
I think that's the same reason why you only see one side of the moon in orbit. It's because there's nothing to spin it back around.
Well, I'm glad you brought that up, because that happens to be a subject in this, and it is something that is, oh, brother, okay, let me say, let me ask you, okay, we have the Earth. What is it that, okay, the Earth is moving around the sun, but what do you suppose, or what do you think the common scientific idea is that turns the Earth like this as it's going around? I'm not sure the direction at this moment, but it's turning one way, and as it's going around. What do you suppose the common idea is? Any?
Oh, centrifugal force, isn't it?
Well, centrifugal force might have...
Centrifugal, not centrifugal.
Oh.
Centrifugal, T-R-I-P.
Okay. Are you referring from like the initial Big Bang they claim, and it's...
No, not that far back.
Okay, maybe I don't understand what that is. Can you explain?
Well, it's the force that keeps it turning like that, because there's two orbits going on. One of it's the orbit around the sun, and this is another orbit that's going around this way.
Exactly.
On its axis.
What's causing that, though?
Right, you got me.
Okay, well, this is what they claim, or what they believe it is. They believe after the initial Big Bang that, not that I agree with this, but that's what they're claiming. The initial Big Bang, the centrifugal force, when it formed the planet over all these years, that initial motion is the same motion that's turning the Earth now. That's what they claim. But there's discrepancies in that, because since the invention of the atomic clock, that they know that sometimes it slows down and then speeds up. So what would account for the speeding up? Because see, over the millions of years, you would think it eventually goes slower, right? But it's staying at the same speed and sometimes going faster.
There's an attraction some way.
Well, this is, okay, the scientists acknowledge that there's interaction between the oceans and the atmosphere. Okay, we're talking about the atmosphere. Okay, if they acknowledge an interaction, the interaction that they believe is that the Earth is turning, causing the seas to turn, and also causing the atmosphere to turn. But if you look at it through another way, or the opposite way of that, is that we know of the immense radiation in space, that this constant bombardment of radiation on the atmosphere is causing the atmosphere to turn, causing the oceans to turn, and that turns the Earth, not the other way around. And to prove this theory, because it's just a theory, is that moons that don't have any substantial atmosphere, they don't rotate. See? So there's some credibility to this, and it makes more sense because they can't explain the speeding up. Okay, now it gets to this thought. Okay, now suppose that this globe was the sun. Okay, the Earth would be about the size of a pea compared to this. How far away would that pea be from that sun?
Somewhere down the road.
Now you got it.
That's the toilets out there.
It'd be exactly where those toilets are, about 215 feet. And it has like the radius. Oh, we have a hand back there again.
Yeah, that heating that you were talking about, that's differential heating. As the Earth goes around in different portions of the year, different parts, because it's on its axis, because there is an axis, it's differential heating that will generate that force.
Right, that's another good idea, because, it is off axis a little, and, all these things that all...
Heating on the globe, it's not always at the same thing, so as it goes through the motion of a season type thing, that differential heating could be the generating force.
Right, but you do see the logic where if it works one way, it can work the other way, and it's more reasonable it's working the unconventional way because the moon's not turning, and that also explains why it can speed up and slow down. Okay. All right, during this IGY year, the International Geophysical Year, there was a team of scientists under the direction of James A. Van Allen. He was an American physicist at the University of Iowa. Now, what they discovered is with the thing, maybe we could use the old blackboard again, Bill. Thank you, Bill.
You mean to tell me not one university has come up with this theory?
They all know.
Oh, do they?
Yes.
They're in on the fraud.
No, they're in on their job and their government grants, which they lose if they don't perpetuate the fraud.
I made that a little too big.
It's all about money, position.
Naive.
Follow the money.
You can't buy everybody, but you can buy most people. What you can't buy, you don't deal with. That's why they don't deal with us. And the rest of the world says because the people who have positions don't deal with us, we have no credibility. See how it works?
Yeah.
Okay, these scientists during this geophysical year with the Voyager with the Vanguard satellite projects, what they did is they kept shooting up rockets with satellites with Geiger counters in them, and they discovered that there was this belt around the Earth here that was accredited to the James A. Van Allen, and that's why we know him as the Van Allen belt. Now, what this is it starts at 600 miles out from the globe here, and up to 25,000 miles, if memory serves, 40,000 miles. That what is causing this is the radiation from the sun hitting the magnetic lines of force of the Earth. Is within those magnetic lines, it creates an ionized field of charged ions, and they attribute that to the Van Allen belt. And they also call it a plasma. That a plasma is a charged particle. Now, one of the significant factors of plasma is that it has a very high conductivity of electricity. As a matter of fact, they say it's even better than copper And so here we have around the Earth here a giant, essentially a giant metal band. Because there's no difference between the conductivity of metal and plasma. So if you know anything about electricity and currents, when you have a current, the left-hand rule, I believe they call it, wherever you have magnetism, motion, or electricity, you have a current. So there's many thousands of amperes flowing through the Van Allen belt, and they discovered that there's high radiation, and it wouldn't be a place I'd really want to go. You know what I mean?
Well, the shorter turn must have an effect somewhere. If you have a shorter turn on the transformer, there's a lot of heat generated.
That's true. To get back to
That's why it warmed up there.
Well, this is at a higher level than what we were talking
That's it for today, folks. You only heard 1 hour of a 2-hour lecture, and that's all you're going to hear on this broadcast, or any other broadcast for that matter. Listen for the announcement of availability of audio and videotapes of the 97 conference. You're going to want to get as much as you possibly can. Those of you who did not attend, you missed a tremendously educational and entertaining and social experience that you just can't get anywhere else in the whole wide world. Good night, folks. God bless each and every single one of you.